Hello everyone, myself Pavani. I am working as assistant professor in CSE AIML department, MLR Institute of Technology. Today I would like to give a session on word level analysis in natural language processing. Coming to the overview of the today's session is introduction about the word level analysis, and next one, what is a regular expression, and next, what is the meaning of finite state automata, and next, find the structure of the words. The basic concepts of the word level analysis. Coming to the first one, word level. What is the meaning of word level analysis? It refers to the examining individual words into text to understand their meaning or form or function. It is used in linguistics. Linguistics is a scientific language. That means from one language to another language, how the text is translated. Linguistics. Next, C, NLP involves different levels and complexities of the processing. Whenever we are processing the text, it contains some different levels and complexities that are there. So, one way to analyze the natural language text is by breaking down into some conscience units. That is called as a consciency parsing. That means whenever we are taking a sentence, we are dividing sentence into tokens. The tokens is called as a units. So let's see what is the meaning of regular expression. Let's see what is the meaning of regular expression. It is a sequence of characters that defines a search pattern or strings within the meaning of the strings. Here the American mathematician Stephen formalized the regular expression language. It is a formula with a special language which can be used to specify simple classes of a strings like a plus b or a star. Like this is some types of regular expressions. Whenever we are giving simply classify the strings, a sequence of symbols. In other words, we can say that regular expression is a algebraic notation. Mathematically, algebraic notation with a set of strings. This is called about regular expression. It requires two strings. One is the pattern and other is the corpus. That means the regular expression requires the two strings. One is the pattern, second one is the corpus. Corpus is some database. That means it contains set of context. That means which type of text we need to pattern the text, that is the corpus. Let's see some regular sets and their properties of the regular expression. First one, it may be defined as the set that represent value of the regular expression that consists of some specific elements. It may be defined as some regular expression contains some properties. Let's see the first one. Union is the one of the property. Like this, A union B. This is A is one set and B is another set. We are in union the A set and B set. The result set should also be regular. This is the one property we have to satisfy the condition. Second one, intersection. So A intersection like this. Next, complement. The result set also would be regular. Next, difference. A, B, two regular sets. The result set also should be regular. Next, reversal. Next, we can take the closure. Next, we can take the concatenation. Compulsory, the result should be regular. These are all the properties of the regular expression: union, intersection, complement, reversal, and closure, and concatenation. Let's see the mathematical representation of the regular expression. Here, a regular expression can be defined as a sigma is a regular expression having the empty string. Sigma, empty string. Pi is a regular expression which indicates that language is empty. Let's see the x and y are the two regular expression. Then x into y is the concatenation. X plus y is the union of x and y. X closure is the clean closure. And x or y, either x or y. This is some declarations of the regular expressions. Let's see the example. Here we are taking the regular expression 3/d 2/d 4/. Here we are taking 1, 2, 3 number. After this, how much is there? 2 and 3 after 2, 4, 5, and next 4. 2 after 4 is there, right? 4, 6, 7, 8, 9. This is the declaration of the regular expression. How we are declaring from 1 to 9 numbers. This is a basic example of the regular expression. Next one. Basic regular expression syntax. This is a /A denotes set containing string A. It matches all the occurrence of the A. That means in sentence how many times A occur, right? It matches all the occurrence of A. Right? Next one. Next sentence, supernova. Here supernova denotes the set containing a supernova and nothing else. It only specifies the word supernova only, not nothing else. Okay. Let's see the some example of the regular expression book. We are specifying here book. We are taking the book, right? Here the word book is, and those who do not travel read only one page. Here the sentence contains a book. Book is a example pattern of the regular expression. Next, see the second example. Reporters who don't read style book should not criticize their editors. Here book is there, right? This is one of the example patterns. Next, see the face. Not everything. Whenever we see the face in a word, in sentence, is a example pattern of the regular expression face, right? We are declaring face regular expression like this, right? Next one, A, reason, observation and experience, right? Next, see the regular expressions, some continuation. The characters are grouped, putting them in the brackets. That means whenever we are writing the characters, we compulsory keep within the brackets. ABC, declaration ABC. Next, from 5 to 9, it means numeric numbers from 5 to 9. It is to specify a range, how many, so any number of between 5 to 9 is a matched. So within these, whatever there in the bracket, this we can match with the sentence, in sentence. Closure of the matches, any character except the X. That means whenever we are specifying the closure, not only compulsory, it is not match this character, suppose A or B, like this, except this A or B. If next, see the example of a table like this. Here the table contains regular expressions and matches some example patterns. Here the regular expression contains only small a, b, c only. So it matches only a, b, c. If some course will start tomorrow. Here what the c is in there, right? It matches with the example patterns A to Z. Some characters capital A to Z. Whenever we can see our sentence capital A to Z, it will automatically matches. Right? Next, closure A to Z. Not only A, it will match to remain B to Z. This is the meaning of this regular expression. Next, closure A, B, C. Here match anything other than A, B, C. A, B, C other than remaining also D to Z. Next, plus or star question mark. Match any of this. And next, A cap, match A or cap. This is some regular expressions definition. Next, continuation of regular expressions. Regular expressions are case sensitive. Here see, Sana matches only with Sana and do not Sana. That means it is a case sensitive. Sana only matches S with the Sana, not Sana. Then whenever we want to match both these, we can write this like this. See. To resolve this problem, we have to define S and small s and capital S. Consider supernovas. Here, accept supernova and supernovas. Use of the question mark makes the previous characters optional. Whenever we have to define the supernova and supernovas, we can define like this supernovas. Next, consider we specify 0. We have discussed in previous, right? Here, B specify 0 or more occurrence of B. Occurrence B, that means how many times, that means all. How many times the B occur, right? Continuation of the regular expressions. Complex regulation can be built up from simpler ones by means of regular expressions operators. Here cat symbol is, right? Cat symbol, dollar. Here what is the meaning or purpose of cat symbol? Use it to match at the beginning of the string. Whenever we are writing A, right? It matches only A. That means dollar used to match at the end of the string. Let's see the example whenever we are writing first example, right? See this. This is a cat symbol. This is a D is the end of the, and S dollar is the end of the string. Dollar we can specify end of the string. Cat is the starting of the sentence. See example, the nature. Cat is the starting and dollar is the end of the string. Here dot is a while character, can be used counting the, whenever we want to count the characters we have to specify this like this. Next hash dot right, matches 6 characters. How many are there? 3 dots, right? How many are there? 3 dots. Berry matches 6 characters, ended the berry. Example 2 berry, like this. It ought to apply disjunction operation, specific time unit to enclose the parenthesis. Whenever we have to define disjunction within the brackets, we can specify. To match blackberries, if parenthesis is not used, it matches with the blackberry, not just berries, only berry, right? This is the right one. We have to define like this, blackberries, right? Next, see some special characters, how we are defining special characters in regular expressions. Dot is the matches, don't matches any single characters. Slash is the new line characters. T is a tab. D digital 0 to 9. Capital D is a non-digital. W is alphanumeric characters. Capital W is a non-alphanumeric characters. Small s is a white space characters. Capital S is a non-white space character. These are all some specific special characters how we are representing in a regular expression. That means how we are using regular expression. We have to know all the basic things of regular expression. It will cover in a compiled design subject in depth. Let's see the example, how we are writing regular expression. This is some basic examples of regular expressions. Some cat symbol A to Z, small a to Z, 0 to 9, underscore, slash, dot, minus or plus, match positive acceptable number of characters at the start of the string. Whatever there in this parenthesis, that will only matches to the sentence. Next, see the finite state automata, FSA, finite state automata. This is a basic concepts in compiled design. What is the meaning of finite state? It is a mathematical model of the computation used to recognize the patterns or language. This is a mathematical representation of whenever we have to recognize a pattern or a language. Pattern is we have to, how we can recognize through finite state automata. There are 2 types of finite state automata: non-deterministic finite state automata, deterministic finite state automata. NDFA, DFA. Okay. So let's see the finite state FSC contains a 5 tuples, right? Q, sigma, delta, Q, sigma, delta, Q naught, comma, F. These are all the tuples in a finite state automata. That means how we are using these states in our diagram. Okay. Let's see. Where Q is the finite state of states, that means some Q equal to Q naught to Qn. These are all the finite number of states. Like next, sigma is the finite input alphabet. That means 0, 1. Like next, Q naught is the start state. That means how our diagram is starting with the Q naught, right? It belongs to capital Q. F is some final states, right? F tends to Q. Let's see the example. Let's see the example. There are 2 types of finite state automata. We have discussed, right? Deterministic finite state automata and non-deterministic finite state automata. Come to first one. What is the meaning of finite state automata? Deterministic finite state automata. A DFA is a finite state machine where for every state and input symbol there is exactly one transition. That means in DFA only one transition will occur, right? In NDFA multiple transitions. See. Multiple possible transition. Let's see the example. Here we are taking 3 states, Q0, Q1, Q2. Here Q0 to Q0 and Q0 to Q1 state, right? here map with the Q0 to Q1 and Q0 to Q0, right? Next, C. This is the only every state to exactly one transition, right? Next, see the example of NDFA, non-deterministic finite state automata. Here it has a multiple possible, that means Q0 to Q1 or Q2, Q3 or Q4. Like this, one state to multiple states. This is the difference between the DFA and NDFA. Very, very important concept in basic concept in a finite state compared design and natural language processing. Next, let's see the finding the structure of the words. How we find out the structure of a word? That means first we have in NLP we call words as a tokens. They are smaller units of a sentence. Whenever you have sentence, we have divided sentence into particular units. That means we call it as a tokens. These are called as a tokens. Usually separated by some spaces or punctuations. Like I love NLP, right? So this is a sentence. We break the sentence into 3 units. That is the first one, second one by using the spaces. It's called as a spaces, right? In this sentence, let's see the example. Will you read the newspaper? In the sentence, will you read the newspaper? How many tokens are there? 1, 2, 3, 4, 5 newspaper. Here newspaper is a single word, right? 3, how many sentences are there? 5 sentences. Here the tokens are will you read the newspaper are the tokens in a sentence. Here the words appear, newspaper are called as a compound words. We are discussing, right? Because they are made by combining 2 words. News plus paper, it is called a single word. So to form a new meaning. Let's see. Words are the basic units of language that can stand alone to form a meaningful sentence, right? By combining the words, we get some meaningful sentence. Right? See the example. In the sentence, the cat sleeps, the words, the cat sleeps are independent units that carry the meaning. By combining all these 3 words, we get some meaning, right? It makes the sense of the one meaning. Next, what is the meaning of morpheme? Morphemes are the smallest part of the words that carry a meaning. Let's see. How many types of morphemes are there? Free morphemes, bond morphemes. Let's see. What is the meaning of free morpheme? These can stand alone. Example, cat, and these are all comes under the free morphemes. Next, see the bond morphemes. These cannot stand alone and need to attach the another word. Example, some we can plural, right? Cats. We are adding here s. This is called as a bond. Here there is a bond between the cat and s, right? After that means multiple, that means plural. Next, words like won't or contractions. That means whenever won't, that means we are adding the t. That means another bond. That means won't, will not. Will plus not. Next, linguistics often prefers to analyze the contractions as 2 separate tokens because each word has own meaning and grammatical role. In linguistics is a scientific language study. That means how language formation is built done by the contractions of the 2 separate tokens. Next, what is the meaning of here tokenization? Whenever we are dividing a sentence, we call it as a tokens, right? What is the meaning of tokenization? Breaking sentence into tokens. It helps analyze structure of sentence. That means how these tokens are helped to form a sentence structure. It is called as a tokenization. Example, will you read the newspaper? The tokens are will you read the newspaper, right? We all discussed, right? Example 2, I won't read it. Tokens, I will not read it. Latter, breaking won't into will not. This is called as a tokenization. This comes all can called as a tokenization. That means meaningful sentence. That means these tokens helps to analyze the meaningful structure. That is called as a tokenization. The next, what is the meaning of, these are all basic things in a word level analysis. What is the meaning of stemming? It involves removing the prefixes and suffixes to find the base form of a word. What is the meaning of stem? Stem means it removes the prefix and suffix to find the base form of a word. Here, example, played is the word. The root word is a play. Next, second one, computerized is the word. Next, compute is the root word. But what is the drawback in stemming is it will not show the exact root word. It will show the nearer root word in database. Next, lexeme. What is the meaning of lexeme? A lexeme is a group of related word forms that share a common meaning. What is the meaning of lexeme in lemmatization? Lexeme is a group of related words forms that share a common meaning. That means whenever we are adding the words, common words, it shares the common meaning. That means same meaning. Example, see the example here. Run, runs, running. Both are same related to the play, right? The lexicon, a language collection of lexemes or vocabulary. Lexemes are divided into nouns, verbs, adjectives or conjunctions. We can divide these lexemes into noun, verbs and adjectives and conjunctions. The base form of lexeme is used as a reference called as a lemma. What is the meaning of here lemma? The base form of a word. That means the base form of a lexeme is called as a lemma. Here lexeme, what is the meaning of lexeme? Lexeme is nothing but related word forms. The group of related word forms is called as a lexeme. The lexeme is called as a lemma. A lexeme is group of word forms. The group of word forms is called as a lemma, right? Changing the form of word to show things like tense, number without changing its core meaning. That means what is the meaning of here lemma? Lemma means it will not change the meaning. It will only change the tense of that particular word. Here see, run is the lemma of runs and running. Both are same. Run and runs and running is the same meaning, right? But it will only change the tense of that particular word. Example, mouse means mouse is a singular and to plural. That run, ran, present tense to past tense. This only change the sense only. Lemma. It's a very important one. Lemmatization, lexemes and stemming and lemma. Next see, creating a new word from another word by adding the prefix, suffix often changes the meaning of parts of speech. Here we are adding the suffix and prefix to the word. Receive. Some here receive is a verb to receiver, noun. Happy, happiness, adjective to noun. How we are adding the prefixes and suffixes. Example, did you see him? I did not see him. I did not see anyone. This is some sentence. The word did not can be break into two tokens, right? Did and not. Here, the word can combine two tokens, any and one, but it has a single fixed element in a meaning. But it has only single element meaning, right? This is all about the basic things in we found in the word level analysis. A summary about what is the meaning of word level analysis, how we are using in find out the words, and next what is the regular expression, what is the meaning of finite state automata, non-deterministic finite state automata, deterministic finite state automata, and finding structure of the word, stemming and lemma and lemmatization, and next tokenization, tokens. This is all discussed in this session. Thank you.